Good morning and welcome back to Math and Engineering Help Desk. After a little bit of an April break, we're back with some more content. In today's video, we're going to be talking about exponent simplification type problems, as well as the rules behind those problems and simplifications. We're going to take a good hard look at some of the rules that we have seen so far and how to apply those rules. So here's a brief overview of the main ones we'll be using in this video, although there might be a couple more that'll also pop up. I can already think of one that's not on this page that you'll see when we get to it. A couple of basic rules that we want to use. The multiplication rule. When we have an identical base with different exponents and we're multiplying those two terms together, the result is a sum of the exponents. X to the m plus n if it was x to the m times x to the n. Note here the bases have to be identical. The exponents, technically, yeah, they can be identical as well, but it also works when they're unique. The same kind of idea here when we're dividing and the bases are the same, x to the m over x to the n, the result would be x to the m minus n. It doesn't matter whether this number on the top is less or more than the number on the bottom, the rule would be the same. For power of a power, when we have a base and an exponent inside parentheses, and then outside the parentheses we have an exponent applied to that, we would actually multiply those exponents to get a resulting base. And lastly, the reciprocal rule. With x to a negative exponent, the result is 1 over the positive version of that exponent. So we'll be applying these rules over 14 different examples in this video. Let's get started. So here's some basic quick ones for you. 3n to the third times 3n to the third. When we multiply, we still multiply the constants normally, so we get 9. And then since this is an application of the exponent rule for addition of the exponents, n to the third times n to the third would be n to the sixth. So that's the answer to that one. For this one here, number 2, we actually have a 0 exponent, and this is the one of the rules that we didn't talk about yet, and that's when we have any base to a 0 exponent that actually equals 1. Oops, that ended up in the superscript. That actually equals 1. And this works for any base as long as that base is not equal to 0. So the rule for that is x to the 0th equals 1 here, as long as x does not equal 0. I'll put a slash through that in just a second, just so you can see that rule right in front of you. Okay, as long as x is not equal to 0, that's always true. Okay, so since that's the case, 3x to the 0th, well, that's going to be 1. So this will really just be 3 times 1, or just 3. So it would be 3 times 2x to the third. That means the answer is 6x to the third. Okay. Number 3, same kind of deal here. We have 3m times 3m to the third. Now the other thing to consider here is it's 3m. There is a hidden exponent here, and that exponent is 1. Okay. So anytime you see a variable without an exponent, the exponent actually equals 1. So 3m to the first times 3m to the third equals 9m to the fourth. Okay, so that's an application of the addition rule there as well. For number 4, same deal here. 2x squared times x is just 2 plus 1 for the exponent, so it's 2x to the third. And then 3v times 2v, that's 6v to the second. With 3 times 2 is 6, v times v is v squared. And then that's an application of those easier problems. Now, let's take a look at the next problem here. 6, and these next 5 problems are going to be sort of a medium difficulty. And let's take a look at all of these. 2y to the 0th, same as before with number 2. That y to the 0th equals 1. Since it's times 2, we don't need a representative 1 there, so we'll just cross that out and ignore that. But here we have a negative exponent. This is our first negative exponent. Now you might be tempted whenever you see a negative exponent to just go ahead and reciprocate that exponent, but I urge you to wait until the end of a simplification problem to see if you have any negative exponents left, because sometimes they will go away. Especially when you're dealing with parentheses, sometimes you'll have negative exponents inside, and by multiplying you actually will end up getting yourself positive exponents. So let's take a look at what to do here. We want to look inside the parentheses. We don't see anything that we can do, so we're just going to distribute this negative 2 exponent into each member of this base. So that means we're going to have 2 to the negative 2 times, I'm going to separate it out just to make it easier to isolate. I'm going to make sure I'm doing, okay, that's right, times x to the negative 6. 3 times negative 2 is negative 6. And this is the power of a power rule that we're using here, times y, in this case, negative 5 times negative 2 is positive 10. And of course, also remember we have a times 2 out here as well. So see what we had here is this exponent, this parenthetical here is now all of this times 2. Let me highlight that just so you can see. This whole thing right here is now all that right there. Okay, and that times 2 is still on the outside. Now I'm going to combined that 2 with this 2 to the negative 2 to get 2 to the negative first, because negative 2 plus 1 is negative 1. So 2 to the negative first times x to the negative sixth times y to the 10th. Okay? I wish there was a shortcut key for superscripts on here. Maybe there is, who knows. Okay, so anyway, now here's what we do. We see we have two values that have a negative exponent. We have one that's got a positive exponent. So when we have a term or expression like this, I like to think of the ones that have negative exponents are going to move into the denominator. They're going to go downstairs, I sometimes will say to my students, and everything else will stay upstairs. So all the positive exponents will stay upstairs, and the ones that are negative, they'll go downstairs so they can become positive. So in this case, this equals y to the 10th. Y to the 10th will stay up top. And then let's add a fraction bar to there. I know there's a better term for that, but we'll make it blue this time. That's fine. And then on the bottom, we'll have 2, because 2 to the negative first is 2 to the first on the bottom, so just 2. And then x to the sixth on the bottom. So that will be your simplified answer. And by the way, simplification, when you're simplifying exponential expressions, they are fully simplified when all exponents are positive and no bases are repeated. So in this case, y, 2, and x are our bases, and there are no no negative exponents to go with it. Okay, so there's our first 6 examples. We've got some more trickier problems to come up, and let's take a look at these. Oops, I got this one's hidden here when I transferred it. I forgot to separate those. Okay, so there we go. There's our next 4 examples. All right, so let's take a look at the next ones here now. So here we got a power of a power inside here. We look inside the parentheses. We don't see anything that we can do, so let's go ahead and distribute that exponent into the parentheses. So x to the negative third, y to the negative fifth, all to the fourth. They'll give us x to the negative 12th, because we're multiplying here, y to the negative 20th. I'm going to ignore the multiplication for now. And then so that parenthetical becomes that. And then we still have on the outside here of that parentheses x to the negative third and y to the negative second. Oops, lost my mouse for a second there. Negative 2. Okay. Now, here we have 2 bases. We have x and y. We have 2 different exponents to go with this. So let's combine these first. X to the negative 15th will be our first. And then we will have y to the negative 22nd. So now, just as before, this time we have 2 exponent bases that need to go down to the denominator. We have nothing left in the numerator, so we have to include a placeholder 1 on the top here. So that 1 will go up here, and then let's throw in our fraction bar. And then on the bottom, we are going to have x to the 15th, y to the 22nd. And those will be on the bottom, and there's your final answer. All right, let's go ahead and go to the next example here. Kind of the same similar example here. We have mn on the outside, mn on the inside. We have a negative here, and we're going to talk about how to deal with that in just a second as well. Now, just as before, we're going to look in the parentheses. We don't see any repeated bases in the parentheses, so we're going to distribute this exponent. Now, let's talk about this negative sign that's outside here, because this negative sign technically is a negative 1 right there, okay? And the way I wrote that, it looks like the m becomes an n. So I'm going to write that just like that. Still doesn't help. Okay, so we're gonna just type it out. So that negative inside is kind of like a negative 1. Okay, negative 1, m to the negative first, n to the fifth, all to the negative second. Okay, so that means we're going to have negative 1 to the negative second, m to the negative, so positive second, excuse me, because negative 1 times negative 2 is positive 2, and then n to the negative 10th, okay? And then that's going to be multiplied by negative 2, m to the 4th, superscripted too soon, m, I did it again. All right, m to the 4th, n to the 4th. Okay, so let's talk about what happens here. When we have a negative 1, or a negative of something inside that's being raised to an exponent, we have to actually treat that separately. And that's an easy mistake for students to make. And in this case, this mistake could actually cost you a point, because you're going to have an incorrect sign in your final answer. When you have this negative and then an exponent on the outside, this is like a negative 1, and that negative 1 would actually get this exponent as well. So a negative 1 to the negative second. Let's look at this separately real quick, because the rule we would use here is that it's 1 over negative 1 to the second, right? So according to our negative exponent rule, that's what that would look like. Well, what's negative 1 to the second? Negative 1 to the second is negative 1 times negative 1. and that's equal to positive 1. So that means that this is going to be 1 over 1, or just positive 1. So the shortcut here is that when you have a negative exponent, negative even exponent to negative 1 or to a negative base, it's actually going to become positive. So in this case, negative 1 to the negative second, when it's 1, obviously it's either 1 or it's negative 1. In this case, it's going to be 1. Okay? So that 1 is going to cancel that negative is going to cancel, and we're just going to have 1. So because we have other terms to go with it, we're just going to cross that off. Okay, now the rest of it. We have m to the second, we have m to the fourth, that's going to be m to the sixth. We also have that negative 2. Let's write that first, that negative 2 out here. We'll write that first. M to the sixth, and then we have n to the negative sixth, right? Because negative 10 plus 4 is negative 6. So with that, we have one exponent that needs to move into the denominator, move downstairs. We have two parts of the base that will stay upstairs. So negative 2m to the sixth. And then we're going to include our fraction bar here, which, by the way, is the official definition, although some mathematicians will say because it's a horizontal line in symbols, we call it a vinculum, V-I-N-C-U-L-U-M. But I like fraction bar, and everyone understands what you're talking about when you say fraction bar, right? And that is the official, that is an official term as well. So anyway, I digress. Negative 2m to the 6 over n to the 6 would be the correct answer here. Now, for number 9, this is an example where we actually can do some simplification inside the parentheses first before we distribute the exponent. And we should do that because otherwise we have 4 numbers we have to distribute to negative 5 and then simplify anyway. We might as well simplify it while it's still of a relatively easy term. So with y and y, we have y and y to the fourth. That's going to be y to the fifth. And negative 5 times x to the negative 2, that's x to the negative 3. So we like to write our variables in alphabetical order as well. So x to the negative 3. And then times y to the fifth. All right, and then we should actually put this in parentheses, and then we will have an exponent of negative 5. So what happens here? Well, when we have a negative 5 exponent here, x to the negative 3, x to the negative 5, that's going to become x to the 15th. And then that will be times y to the negative 25th. Okay, so with that, again, we have one part of this that's going to move downstairs. It's the y. So the x to the 15th will stay up top. And our fraction bar, I should just copy and paste this fraction bar, but it is varying length each time. And then y to the 25th would be on the bottom. Okay, and there is your final answer for that. Now, number 10, we have this particular same kind of problem with number 9. We have some simplification that we can do. However, note we have a negative 1 again, and we have a 2. But this time, these are going to be raised to the third power, so actually that will stay negative when we get to that step. So let's go ahead and write what's in the parentheses first, just like before. Negative 1 times 2 is negative 2. X to the negative first times x to the negative third. See what I'm doing here is I'm multiplying where the bases are the same. X to the negative first times x to the negative third is x to the negative fourth. And then y to the negative 2 times y to the third, that's just y. I'll write y to the first just to make the point, but you don't need to write the 1 there. And then we will be raising that to the third power. Okay, so let's go ahead and do that. Each of these bases will be raised to the third power. When the base is negative, and actually what I should do here, let me further note this, that we're going to be using a negative 2. It really is like negative 1 times 2, but it's negative 2. We can kind of combine those into 1. So I'm going to actually put this in its own little bracket just to delineate between those two things. We can combine them to one base. Negative 2 to the third, what does that mean? When you have a negative base to an odd exponent, the result is negative. So it's going to be negative 8. 2 to the third is 8, right? Negative 8, and then we have x to the negative 12th and y to the third. All right? Now we have only one of these numbers that needs to move downstairs. It's x to the negative 12th. Some of you may be tempted to say that the negative 8 needs to go downstairs as well, but negative 8 doesn't have a negative exponent. Negative 8 is just negative 8. So we can leave that up there, upstairs, as we say, and that does not move downstairs. It would only, if it was a negative exponent, would it move downstairs. So 8y to the third, negative 8y to the third will be up top, and then we'll fraction bar. And on the bottom, we will put x to the 12th on the bottom. Okay? So that takes care of that example. All right, we have 4 more to go. These ones are a little trickier, and let's kind of go through these in a case-by-case basis. So the first one, we have a number 11 here. We have a 0 exponent. Anytime we have a 0 exponent, we want to look at that right away because that's going to be something we can simplify quickly. Y to the 0th is just 1. 1 to the 4th. Anytime you have 1 as your base, positive 1, doesn't matter what the exponent is, even if it's 0, it's going to be 1. So this whole thing on the bottom is actually going to be just going to become 1. So we're going to cancel that, just put a 1 there. Okay? On the top, though, we have something that we can simplify. We have a parenthetical with an exponent. Let's simplify that real quick. Let me see if I can write this out. Let's see how my mouse skills are doing today. We have x to the 4th, right? We multiply 1 times 4, it's x to the 4th, and we have y to the 8th here, right? So x to the 4th, y to the 8th is what that whole thing here becomes. We still have on the outside x to the 4th, y to the 2nd. So when we multiply those out, we're going to get x to the 8th times y to the 10th. 2 plus 8 is 10, right? And then since that's all over 1, we don't need to write that denominator. So our answer is just x to the 8th, y to the 10th. For number 12, we have a slightly trickier problem. We have a couple of things going on. We can simplify inside the parentheses first, and we should do that. But this time we have our first case of needing the division rule. So inside the parentheses, we're going to have n to the 3rd, m to the negative 3rd, n to the negative 3rd, m to the 4th. Let's simplify these common bases first. N to the 3rd times n to the negative 3rd, that's n to the 0th, right? So if that's n to the 0th, we actually just get 1. So these two things right here will actually just cancel out n to the 0th, right? N to the 0th is just 1. But we have this m to the negative 3rd divided by m to the 4th. Now our rule here is we need to subtract the exponents. So we got negative 3 on the top, 4 on the bottom. That's going to be m to the negative 7th. And further, we have this negative on the outside. So this whole fraction here just simplifies to m to the negative 7th. So that's m to the negative 7th, and then that whole thing is being raised to the negative 4th power. Okay? Now, again, we're going to apply these separately. Negative 1 to the negative 4th is positive 1 for the rule we mentioned before. It's an even exponent. This would simplify to 1 over negative 1 to the 4th. 1 to the 4th is just positive, negative 1 to the 4th, excuse me, is positive 1. So this is going to become a positive value. M to the negative 7th to the negative 4th is just m to the 28th. And that is that. That's all we need to do for that, right? So this whole thing, it looked complex at the start, really just amounts to m to the 28th. Pretty high exponent, of course. Okay, 2 more to go. Now, here we have a couple more combination rules. We want to take care of these separately. We have parentheses on the bottom. We have stuff on the top. We have a negative on the outside. Whew, we got a few things going on in here, so let's go ahead and take these one thing at a time. We have a negative y to the 4th to the negative 2nd. So as before, negative y to the 4th to the negative 2nd, that's negative 1 to the negative 2nd, that's positive 1. 4 to the negative 2nd is y to the negative 8th. So that's y to the negative 8th in the bottom for that first term. Then we have this negative 2 x to the 3rd all to the 4th. Well, negative 2 to the 4th, that's an even exponent, right? So that whole thing here is going to become 16. Negative 2 to the 4th is positive 16, x to the 12th, okay? So if I have this and I have this, that means my denominator is going to combine and become 16x to the 12th, not f12th, y to the negative 8th. And x to the 12th, y to the negative 8. That's the whole denominator, right? Now, let's write that numerator that we have up here. And also don't forget that we have a negative on the outside as well, not x negative. We have that negative on the outside as well. And then we have this x to the negative 3rd, y to the negative 3rd as well. Okay, now, let's go ahead and look at these. We have common bases here. We have common bases here. Let's simplify these. X to the negative 3rd minus x to the 12th, or negative 3 minus 12. That's going to be x to the negative 15th. And well, actually, yeah, let's write x to the negative 15th. I thought about maybe there would be a simpler way we can write that, but not really. We're just kind of using this as a teaching moment right here. But negative 3 minus negative 8, that's actually y to the 5th, to the positive 5th. Okay? Now, we don't have anything that we can simplify with that 16 on the bottom, but understand that it is there, and it's negative, and the whole thing is still negative, right? So there's a lot of things going on here. That 16 is still on the bottom. That x to the negative 15th, we're writing it on top for now, but we are going to be moving it because it's negative. All right. And the last thing we have to do here, all of our bases, we don't have any unique bases that are repeated. So this x to the negative 15th just has to move downstairs. So our final answer is negative y to the 5th on the top, and on the bottom is going to be 16x to the 15th. Okay, so that's our number 13th problem on the video. Now we have one more to go, and it's this one right here. So just like before, we have some repeated bases, we have some repeated exponents, we have some simplification that we can do right away. U to the 0th is 1, so we can just cross that out, right? Because we have a 2 on the outside, so it's 2. And it's 2 times 2, so that's going to be 4. And then we also have u to the 4th, v to the 2nd on the bottom. Upstairs, we have a negative exponent that needs to be applied inside of this parentheses. So let's do that first. Let's do that part first. So on the top, negative 1 to the negative third is just negative 1, so it's still going to be negative. Negative u to the negative 6th times v to the positive 12th. And that whole thing is going to be over. Let's just do that quick little multiplication here with 2 times 2, if you don't mind. Let's write that as 4 u to the 4th and v to the 2nd. Okay, now, so here's what we got so far. We have 2 repeated bases here, say negative 6 and 4. We also have a negative 1 over 4, so we know that we're going to have negative 1/4. I'm going to just put that to the side just for a second, so then we can multiply that back in. So negative 1/4, I'm going to write it horizontally if you don't mind. And then we have on the top here, we have u to the negative 10th, negative 6 minus 4. And then we have v to the 10th, positive 10th, positive 10th. Okay? So now, that u is going to go downstairs, that v second is going to stay up top. Negative 1/4, so that we're going to have negative on the outside. The easiest way to write that is to put the negative on the outside, negative. And then here's our first part. On the top, we have just v to the 10th on the top. Right? We don't need to write 1. We can if we want to, but we don't need to. And that will be over. Now that 4 is on the bottom. We still need to write that. So that's going to be 4 on the bottom. And then that u to the 10th is going to go on the bottom and join it as positive 10th, u to the 10th. Right? So our final answer is negative v to the 10th over 4 u to the 10th. And that is that. So hopefully these examples help shed some light on how to simplify exponents. Thanks for making it to the end of the video. If you made it this far, please do me a favor, hit that like button, and go ahead and subscribe to Math and Engineering Help Desk, where we're kind of posting some helpful algebra videos and pre-algebra videos for your consumption this year. Hopefully we end the year on a high note. Have a wonderful rest of your day, and don't forget to be awesome.